All right, so let's go ahead and continue with some more factor by grouping by looking at 13, 14, and 15. And let's go ahead, I'll go and rewrite our questions out here so we have a little bit more room to work with. Minus 2xz plus yz. All right, so these are going to be a little bit more difficult, but we're going to use the exact same steps and process that we did with the first set of factoring by grouping. So we see that we have four terms, right? 1, 2, 3, 4. So that tells us we're going to be factoring by grouping. And let's go ahead and isolate the middle sign. And when we do that, that splits it up into a left and a right. And let's just take a look here at the left and see what's in common here on the left. Well, we have a 16wx minus 8wy, and so it looks like we're going to have an 8w as our common denominator, right? 8 goes into itself once, 8 goes into 16 twice, w and w. So if we pull that out, what are we left with? Well, let's see. 8w times what gives us 16wx, and that'll be 2x, and then minus 8w times what gives us negative 8wy. Well, that's just y, isn't it? All right, let's go ahead and now bring this middle sign down and start the process over again. What's in common now here on the right-hand side? Well, it looks like just a z, right? That's the only thing they have in common, so we'll take out that z, and when we do, what are we left with? Well, negative z times what gives us negative 2xz. Well, that's just going to be a 2x. And negative z times what gives us a positive yz. Well, negative z times negative y gives us a positive yz, doesn't it? And we can see that the sets of parentheses we're working with match identically, so that's good. Let's go ahead and pull it down. And when we do that, we can go ahead and cross out those sets of parentheses. And what are we left with? 8w minus z. And there you have it, number 11, or 13 rather. We factored by grouping. All right, let's take a look here at 14. Excuse me. 4x squared y cubed plus 9x squared plus 20y cubed plus 45. All right, so we have definitely more complicated, right? We have some higher powers here. We have multiple variables, but let's not let that scare us. We're going to treat this just like we've been doing. So we have 1, 2, 3, 4 terms. So we're going to split this right down the middle and isolate that middle sign. And now on the left-hand side, let's take a look and see what we have as being in common. Well, if we start with our numbers, those coefficients, 4 and 9, well, other than 1, they really don't have anything in common, right? So we can't take out any numbers. And here we have an x squared, and here we have an x squared, so let's go ahead and take out that x squared. We have a y cubed here, but no y's in this second term here, so we can't take any y's out. So really, that's it. We can only take out an x squared. And now, let's go ahead and, to figure out what's remaining, let's use that, that tool, that little trick that we used in the earlier videos where we rewrite the original expression, and then underneath that original expression, every term of that original expression, we're going to put the common denominator. And I think that'll help us to see what's going to be left after we factor out an x squared. All right, so once we factor out an x squared, well, looking at this, our x squareds are going to cancel, so we're left with just 4 times y cubed, so 4y cubed. All right, and here we're going to have our x squareds are going to cancel, so we're just left with a plus 9. All right, we're going to bring down this middle sign and take a look at the right-hand side now. All right, so we do have coefficients here, and it looks like 5 is going to be in common, right? 5 goes into 20 4 times, 5 goes into 45 9 times, and I think that's going to be the largest number that works for us. So let's go ahead and take out a 5. And, well, we have a y cubed here, but we have no variables here in the second term, so we can't take out any y's, so it looks like just a 5 is coming out. All right, well, we can do the same thing over here. We can rewrite the original expression that we're dealing with. And underneath each term of this original expression, we'll write the GCF that we took out. And now we can say 5 goes into itself once, 5 goes into 20 4 times. And we're left with our y cubed. So 4 times y cubed is 4y cubed. And now 5 goes into itself once, 5 goes into 45 9 times. So we're just left with a plus 9. And when we do that, we'll look at that. Our parentheses match identically. So let's go ahead and we can pull those, or that rather, down. So they go away here. And now what are we left with? Just an x squared plus 5. And there we have it. Number 14, factored by grouping. All right, let me get rid of this here, give us some more room to work. And we'll take a look at number 15. And number 15, we have m cubed plus 3m squared p squared minus 10mp minus 30p cubed. All right, well, again, 1 term, 2 terms, 3 terms, 4 terms. So we are splitting this right down the middle, isolating that middle sign. And now let's take a look here on the left and see what's in common. Well, we have a 3 here, we have a coefficient here, but we don't have anything here. So we're not going to be pulling out any numbers. How about, well, we have m cubed here, but only m squared here. And you'll recall from the earlier videos, when we're working with variables and their exponents, we only take out the smaller exponent. So what's smaller between 2 and 3? Well, 2 is, right? So we can go ahead and take out a m squared. And we have a p squared here, but no p's in this first term here, so we can't take anything else out. So it looks like just an m squared, will be coming out. All right, well, let's go ahead and rewrite the original term that we were working with. So we had m cubed plus 3m squared p squared. And underneath each term of that original expression, we're going to write the common denominator that we pulled out. And when we do that, well, this first reduction here, are we top heavy or bottom heavy on m's? Well, we're top heavy by how many? Well, 3 minus 2 gives us 1, so we're left with just an m. And then here, let's see, the m squareds cancel, and we're just left with a plus 3p squared, so plus 3p squared. And now this minus sign just comes down, and now we're going to take a look and see what's in common here on the right-hand side. Well, now we do have coefficients, don't we? So, I think 10 is definitely going to be coming out with us, right? 10 goes into itself once, 10 goes into 33 times. And have an m here, but no m's here, so we can't take out an m, but we have a p here and a p cubed here. So again, if that's a p to the first and this is a p to the third, we always take out the smallest number of p's, the smaller exponent. So we can only take out a single p here. And it looks like that's it. So again, let's go ahead and write what we were originally working with. So we had a mp minus 30p cubed, and under that we took out a 10p, took out a 10p, and actually we don't really need that negative there. All right, so let's see what is going to happen. Well, the 10 and the 10 cancels, the p and the p cancel, so what are we left with? Just m. And then 10 goes into itself once, 10 goes into 33 times. And are we top heavy or bottom heavy on p's? Well, we're top heavy by how many? Well, 3 minus 1 gives us 2. And so we're left with negative 3p squared. So negative, but hold on here, let's see what I did. But we actually want this to be, because we have a negative out here, this is actually going to be a positive, isn't it? Because negative 10p times a negative in here is going to give us a positive, but that's not what we had originally. So we need a negative times a positive here to give us the original negative. So I guess we have to make sure we watch our signs, right? All right, but it's still going to be our 3p squared. All right, and if you went ahead and did that like I was about to do, and if you got a minus here because the minus was originally here in the original expression, well, you would see right away that these sets of parentheses don't match, and so that is a sign, a clue that you've got to go back and double check yourself. And so we would have done, well, negative 10p times negative 3p squared gives us positive 30p cubed. So we know that this sign here in our second set of parentheses is not correct. So we want to make sure that's a plus. And simply by making it a plus, well, now we have matching sets of parentheses. If we were to distribute this out through our set of parentheses, we would get the original expression. So we know that we factored correctly. All right, so now we have m plus 3p squared. So that can go away, and what are we left with? Just m squared minus 10p. All right, and there you have it. And you know what, how about we go ahead and FOIL this one out, just so that we can go ahead and review how we would check ourselves on a test, right? So make sure that on a test, you're checking yourself, because you can make sure that you factored correctly before you leave. You know, if you have, 10 or 15 minutes that you finished early, don't leave. Use every bit of time that you have and go back through your test and check yourself on the problems that you're able to actually do a self-check. All right, so let's go ahead and we'll take these two terms here and we'll FOIL them out. So m times m squared is going to give us m cubed. M times negative 10p is going to give us negative 10 mp. And then we're going to have, let's see, 3p squared times m squared. Well, that'll give us plus 3m squared p squared. And 3p squared minus 10p is going to give us minus 30p cubed. Let's see, we have 1, 2, 3, 4 terms, so that works. And now let's make sure that we have all of the original terms. m cubed, so that works. Negative 10mp, negative 10mp, so that works. Plus 3m squared p squared, plus 3m squared p squared, so this works. And minus 30p cubed, minus 30p cubed, so that works. So we know, yes, we did factor correctly, and actually, this is the answer, right? These two factors. All right, so again, to check yourself, you can FOIL each of your factors and make sure you get back to the original expression you were working with.